Hello, welcome back to this lecture on spherical polar coordinates. In the last lecture, I have discussed uh, what is meant by spherical polar coordinate, then what is the relationship between Cartesian coordinate and spherical polar coordinate, and we also derived uh, some of the formulas. Okay, what I am going to do in this lecture is I am going to show you some simple problems. Okay, that is how to convert if a point is given in Cartesian coordinate into the corresponding spherical polar coordinates. Okay, yeah, let's get started. So what we discussed in the last class is that in spherical polar coordinate, I have told you if a point is given in Cartesian coordinate x, y, z, we can find the corresponding point in spherical polar coordinate. Okay, in spherical polar coordinate we use the variables r, theta and phi. Okay, what is r? R is nothing but distance between the origin and the point in 3D space. What is theta? Theta is the angle between plus z axis and the line joining the origin and the point. The angle between these two, okay, plus z axis and the line joining origin to the point. That angle is nothing but theta angle. What is phi? Suppose if I draw a projection of the point to the xy plane, then the angle between plus x axis and the line joining the origin and the projected point. Okay, that angle is what we call as phi angle. All these things we discussed in the last class. Now, and we also showed you what is the relationship between these two. What is the relation? X is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. Okay, we derived these relations in the last class by making use of some of the triangle properties. Okay, Pythagoras theorem and all. Now, and we also discussed that what is the if a point is given in Cartesian coordinate, how to find the r value, theta value and phi value. Okay, yes, what is the relation? R is equal to square root of x square plus y square plus z square. If the values are given in x, if the point is given in Cartesian coordinate, that is if x value, y value and z values are given, take the squares of those values, add them and take square root, you will get r. Okay, then how to find the value of phi? Phi is equal to tan inverse of y by x. Take the value of y and take the value of x, find this ratio and take tan inverse of that ratio. That will give you the angle phi. Once you know r, you can calculate theta by using this formula. Z is equal to r cos theta. Okay, if you know the value of r and if you know the value of z, yes, you can calculate the value of cos theta. Okay, yeah, so these things we discussed in the last class. Then one more point I like to make here. What is the range for these r value, theta value and phi value? Okay, the range, range. Or suppose if a point is present exactly at the origin, then r value is 0. And you can keep a point anywhere from origin. It can even go to infinite distance. Therefore, the range for r is 0 to infinity. R value can go from 0 to infinity. What is the range for theta? Theta is nothing but the angle between plus z axis and the line joining the origin to the point. Okay, suppose if the point is present exactly on the plus z axis, then the angle theta is 0 degree. As the particle move away from z axis, plus z axis, angle increases, theta increases. Then when the particle comes to minus z axis, then the angle becomes 180 degree. So for theta, the minimum possible angle is 0 and the maximum angle is 180 degree. 180 means pi in radians. Okay, then what about phi angle? Phi angle, last class I told you, you draw a projection of the point to the xy plane. Okay, then connect the origin to the projected point using a straight line. Then what is the angle phi? Phi angle is nothing but the angle between plus x-axis and the line joining the origin to the projected point. Okay, that angle is nothing but phi angle. If suppose if the point is present exactly on the plus x-axis, then the angle phi is 0 degree. As the particle move in anti-clockwise direction from plus x to plus y to minus x to minus y, then again comes to plus x-axis, right? If the particle moves in anti-clockwise direction, what will happen? Phi angle will increase. If the particle comes to plus y, suppose, I'll say like this. Suppose if the point is present exactly on the plus x-axis, phi angle is 0. Then if the particle moves in anti-clockwise and reaches plus y-axis, the angle becomes 90 degree. Then if the particle moves further and reaches minus x-axis, the angle becomes 180. Then when the particle moves again and reaches minus y-axis, okay, you will get 270. When the particle comes to the initial point, this is the initial position, then that is the plus axis, x-axis, you will get 360 degree. So for phi, the minimum possible angle is 0 degree, and the maximum is 360. 360 means 2 pi. So these are the ranges of r, theta and phi. Okay, then. Okay, just to understand this spherical polar coordinate and Cartesian coordinate, I'll give a problem. We will discuss one simple problem. Suppose, assume that I have a point in Cartesian coordinate space as 2, 2, 1. So this is actually a Cartesian coordinate. Now the question is, what is the corresponding spherical polar coordinate of that point? Okay, so this is x value, and this is y value, and this is z value. So x value, y value, z values are available. Now we need to convert this into spherical polar coordinate. How to do that? Very simple. You know the formula. What is r? R is equal to square root of x square plus y square plus z square. Right here, r equal to square root of x square plus y square plus z square. Okay, and here x value is 2, y value is 2, z value is 1. Okay, so if you take the square, 2 square is 4, 2 square is 4, 1 square is 1, and if I add them, I will get 9. Okay, square root of 9 is 3. So the value of r is 3 in this case. For this point in Cartesian coordinate space, the corresponding value in the value of r in spherical polar coordinate is 3. What about theta? What about phi? First we'll find out phi. Phi is nothing but tan inverse. We know the formula. Tan inverse of y by x. You know the value of y and you know the value of x. Y value, x value, both are 2 here. So if you put 2 in the numerator and 2 in the denominator, 2 by 2 is 1. So what we'll get is tan inverse, y value is 2, x value also 2. So I'll get tan inverse of 1. Okay. You know very well tan 45 degree equal to 1. Therefore, tan inverse of 1 should be 45 degrees. So the phi angle should be equal to 45 degree. Simple. Then what is the value of r? If you know the value of r, what's the value of theta? If you know the value of r and z, yes, you can calculate theta. How? You know very well. Z is equal to, right here, z is equal to r into cos theta. Z value is 1 here. What's the value of r? R is 3 into cos theta. So what is cos theta? Cos theta equal to 1 by 3, or theta equal to cos cos inverse of 1 by 3. Cos inverse of 1 by 3, okay, is 70.5 degree. You can find this using the tables, or by using calculator you can find this value, 70.53 degree roughly. Okay, so if a point is given in Cartesian coordinate, we can find the corresponding spherical polar coordinate of that point using these formulas. Okay, I hope you have understood this concept clearly. Now let me move on to the next one called the Jacobian, which is very, very important actually. Jacobian. Very specifically in quantum mechanics, to find the area element or to find the volume element, we use the idea of Jacobian. Jacobian is actually a determinant. Okay, I'm not going to discuss in detail about the Jacobian. I'm going to show you only the application part here. For example, let us consider a particle is moving in an xy plane. Okay, this is x-axis and this is y-axis. Perpendicular axis is z-axis. I have not shown z-axis here. Okay, suppose we have a point P here, some point. Okay, now what is the how to represent this point in spherical polar coordinate? Okay, this is the origin. So the distance between the point to the origin is r, and the angle between the line joining the point to the origin to the plus x-axis, this angle is nothing but phi. Okay, the same point you can also represent in Cartesian coordinate as x comma y. Okay, now what is the relationship between x and y? Yes, very simple. You just draw a straight line to the you draw a perpendicular line to the plus x-axis. You will get a triangle OP. Let me take this as Q. In this triangle OPQ, okay, this is opposite side and this is hypotenuse. Okay, so hypotenuse is R and this adjacent side, right, is X and the opposite side is Y. Okay, and by applying the triangle property, right, for right angle triangle, you know very well, sine phi is opposite side by adjacent, opposite side is y, adjacent side or hypotenuse is r, sine phi is nothing but opposite side by hypotenuse, opposite side is y, hypotenuse is r, therefore y is equal to r into sine phi. Right? Similarly, cos phi is equal to adjacent side by hypotenuse, adjacent side is x here and hypotenuse is r, so x is equal to r into sine phi. Okay, so x is equal to r into sine phi, this phi, sine phi, and y is equal to r into cos phi. Remember, this point is moving in xy plane, therefore the angle from plus z axis to the line joining origin to the point, right, that angle is 90 degree always, as long as the particle present in the same plane, right. Theta angle does not change. So here theta is constant. Okay. Now for this point, now what I am going to do, see, I will take a small area element here, that is dx into dy. Dx into dy is the small area element in the xy plane. Now what is the corresponding area element in spherical polar coordinate? Okay. So to find that, so we have two variables r and phi, so dr into d phi, right, and we should get some quantity here, that is nothing but Jacobian. Okay, so to find the area element, right, in spherical polar coordinate, you can use this relation. Now how to find the Jacobian? Jacobian is nothing but, very simple, dou x by dou r into dou x by dou phi, then dou y by dou r into dou y by dou phi. This determinant is nothing but Jacobian. Very simple. Okay, now we'll find out the determinant and we'll substitute that here. What is dou x by dou r? X value is available here. So dou x by dou r, let me write here. I'll write here itself. Dou x by dou r, dou x by dou r. And here r and phi are independent variables. Therefore, dou x by, when you differentiate x with respect to r, keep phi as constant. Therefore, dou x by dou r is nothing but sin phi here, sin phi. And what is dou x by dou phi? While differentiating with respect to phi, keep r as constant. So, I'll keep r as constant, and the sin phi, if you differentiate, you will get cos phi. Right? Similarly, we'll differentiate y. Dou y by dou r. Dou y by dou r is cos phi, and dou y by dou phi, let me write here, dou y by dou phi equal to r. Cos phi, if you differentiate, you get minus sin phi. Minus sin. So dou y by dou phi equal to minus r into sin phi. Okay. Now, I'll substitute all these values here. So j equal to determinant of dou x by dou r is sin phi. Dou x by dou phi is r into cos phi. Dou y by dou r is cos phi. Dou y by dou phi is minus r into sin phi. Okay. If I cross multiply this, what will I get? Minus r into sin square phi. Then here we get minus r into minus r into sin square phi and minus r into cos square phi. Okay. If I take minus r common, I'll get sin square phi plus cos square phi, which is equal to what? Okay. So we'll get minus r. Okay. And we have to take only the magnitude here. Okay, because since we are finding area element, minus sign has no meaning here. Okay. Therefore, the value of Jacobian here is r. Substitute that r here, so you will get the area element, right, in spherical polar coordinate. So dx into dy equal to r into dr into d phi. Right? In a similar manner, for particle in a 3D space, okay, we'll calculate volume element, right? Volume element d tau in 3-dimensional space is equal to, you know this, dx into dy into dz. In Cartesian coordinate, volume element is dx into dy into dz. Now the question is, the volume element in spherical polar coordinate is how to do that. We'll use the idea of Jacobian. So dx into dy into dz is equal to, in 3D space, r, theta, phi, all are variables. So dr into d theta into d phi, and put the Jacobian. And remember, Jacobian is a positive value here, because you are finding volume. Volume, area cannot be negative, so it should be positive value. Right? And what's the Jacobian here? Jacobian equal to, we have to find the third order determinant containing dou x by dou r, dou x by dou theta, dou x by dou phi, and dou y by dou r, dou y by dou theta, and dou y by dou phi. Similarly, dou z by dou r, dou z by dou t, dou theta, and dou z by dou phi. Okay. If you differentiate here, x, r, theta, phi, these are all independent variables. Therefore, if you differentiate x with respect to r, x with respect to theta, x with respect to phi, okay. Similarly, if you differentiate all these quantities, and if you substitute in this determinant, okay, I'm not going to do that. It's a very simple one. You just try to do and find out. you will get this as the final answer. That is r square into sine theta. You just work out and find out. Okay. So the area element d the volume element d tau in spherical, in Cartesian coordinate is dx into dy into dz, whereas in spherical polar coordinate, which is nothing but r square sine theta, is the Jacobian into dr into d theta into dphi. This is the volume element in the spherical polar coordinate. Okay, yeah. So I hope you have understood this concept clearly. Right? I'll stop here. We'll continue with the next important aspect of quantum mechanics.